Welcome back. So far, this module has asked you to make charts. Today, we turn the chair around and ask you to judge them. That sounds like the easier job, isn't it? But it isn't. Most feedback on visualization dies at the level of taste. Someone says the colors are ugly, the author shrugs, and nothing changes. By the end of today, you will have a protocol that survives that shrug. Because every judgment you make will trace back to something the two of you can point at together. So think about this scenario that I'm going to explain in the next slide. I want you to imagine, just for a second, that you are sitting at your desk. You're a student, have got a million tabs open, and you're staring at this digital dashboard for a project. And on the screen, there is this jagged red line, and it is trending sharply downward. I mean, in roughly 3 seconds, your brain fires off this massive distress signal like we are losing money, or my grades are going down, or this whole campaign is just failing. So you make the snap judgment. You send a frantic email to your group text, your WhatsApp group. You change your whole strategy. But what if your brain just completely lied to you? That is a big question, isn't it? What if the designer of that chart inverted the y axis? Or they altered the baseline and that downward red line actually represented a I don't know, a massive decrease in overhead costs, which would be a great thing, by the way, but you didn't just misread a chart. You made a critical strategic error because you assumed your eyes and your brain were naturally speaking the exact same language. It is a phenomena we see constantly in this field. People experience this really profound overconfidence when interacting with visual data because it just looks so simple, right? There is this cognitive assumption that because a chart uses geometry and color things that our brains process pre attentively in like literal milliseconds, the underlying data must be intuitively obvious, like it does the thinking for us. We bypass our critical faculties entirely because the visual format just feels inherently truthful. We see a splash of color, a rising line, and we just assume the analysis is done. Or is it? We'll explore exactly how experts measure our human ability to read charts in a nutshell. Why lacking this skill is honestly just as dangerous as being unable to read a legal contract, and how you can objectively evaluate the visualizations. And our core knowledge for this lecture is really rigorous piece of psychometric research. So, if you think about evaluating a visualization, we need to have a standardized instrument. Otherwise, people will not be able to objectively assess a visualization. So, this is fundamentally grounded in psychometrics to measure exactly where the visualization lies in this ease of reading. So, why does this even matter? The importance comes with the availability of data visualizations. It is built around the concept of data democratization, which is a huge buzzword right now. But it makes sense. I mean, we aren't in the 1990s anymore, where complex data sets were just locked on massive mainframes and only passed by, statisticians and lab codes. Data is literally everywhere now. It is in our fitness tracker, our daily news feed, social media infographics, government policy briefings. You cannot escape it. You can think of many ways in which data is linked. So, our information architecture over the last decade has been changing. Data democratization means that access has widened, but, and this is a crucial part, access does not equally mean that the comprehension is equal. Visualizations are the primary vehicle for this democratized data because they are remarkably concise. I mean, you can compress millions of rows of messy spreadsheet into a single visually attractive graphic. But there's a danger there, right? The danger lies in the persuasive power of that compression. Because if you compress millions of rows into one single graphic, you are inevitably making editorial choices about what to highlight and what to obscure, which means you, the reader, need the critical capacity to interrogate those choices. In simple words, you have to have the ability as a reader to understand what that visualization is about. So we have to define this in traditional prose literacy. The ability to use written information to function in society and achieve goals is is what we mean by traditional prose literacy. And the researchers in the visualization domain has defined this parallel to the traditional prose literacy. They define it as the ability and skill to read, interpret, and extract information from data visualizations. So it is basically a direct functional equivalent to reading text. If you cannot extract accurate information from a visualization today, your ability to participate in modern civic and professional life is frankly compromised. And studies consistently demonstrate that visualizations are highly persuasive. If you present a claim with a chart, it is believed at a significantly higher rate than the exact same claim presented as just as plain text, even if the chart is basically meaningless. Therefore, if a user lacks the literacy to deconstruct that visual encoding, they are uniquely vulnerable to manipulation, whether that's from a poorly designed corporate dashboard at your job or a deliberately misleading political graphic on your newsfeed. Okay, let me ask you a question. Is reading a scatter plot truly a literacy in the same way that reading English or Mandarin or Sinhalese is a literacy? Because language requires years of explicit instructions, right? You have to map completely arbitrary symbols to concepts. But visual processing, like perceiving that one bar is taller than another, or that a cluster of dots is grouped tightly together, that relies on our biological visual cortex, it feels innate. It doesn't feel like a constructed grammar we have to sit down and memorize. It is the difference between perceptual processing and conceptual processing. The ability to detect that a bar is taller is perceptual, it's innate, it's driven by Gestalt principles of vision. But the ability to map that physical height to a conceptual variable, say, understanding that a taller bar represents a higher frequency of specific demographic in a survey, that is entirely learned. It relies on arbitrary conversations we have developed over the last few centuries. If you don't possess the learned schema for a specific chart type, your visual cortex can process all the colors and shapes perfectly, but you will still completely fail to extract the meaning. It is the difference between hearing the phonetic sounds of a foreign language and actually understanding what the vocabulary means. To put this into a framework, we can use a three-level hierarchy of cognitive effort. Level 1, which is just reading the data, it is a basic extraction task. You are simply scanning the visual field to locate a specific explicit value, like finding a point on a map. So if you have a line chart mapping a company's stock price over a year, a level one task is finding the data point for March 15th, for example, and reading the corresponding price on the y-axis. The cognitive load is very low. It is literally just a simple lookup operation. Okay, so that's easy enough, right? Then moving up the hierarchy, we hit level 2. If level 1 is finding a single coordinate, level 2 must involve synthesizing multiple coordinates, right? You are shifting from extraction to relation. You are comparing two bars to determine a magnitude difference. Or maybe you are analyzing the slope of a line segment to determine the rate of change between two periods, which is harder for the brain to do, right? This is exactly why it requires you to hold one value in your working memory while you visually locate the process and process the second value and then perform a mental comparison which introduces way more friction and obviously more room for error. The effects of this framework is level 3, reading beyond the data. This suggests an explanation. It's an extrapolation. You are no longer just looking at the pixels on the screen. You are generating information that isn't explicitly drawn. You are making inferences. So, given a scatter plot showing, let's say, strong positive correlation between study hours and test scores, for example, a level 3 task involves predicting a student's score based on a study time that isn't even plotted on the graph. So, that's an extrapolation. So, you have to internalize the pattern, right? You are synthesizing the visual trend, applying an internal mental model of causality, and generating a prediction. And the idea of this nature noted that as you move from level 1 to level 3, user error rates spike dramatically because you are experiencing more friction. Anyone can point to the tallest bias, but forecasting a trend requires a pretty robust understanding of the underlying mathematical relationship that the chart represents. So, if the goal is to build a standardized test, the immediate methodological hurdle is deciding what to actually test. There are literally thousands of ways to visualize data, from basic pie charts to incredibly sophisticated data infographics. Therefore, the test has to reflect the actual visual diet of a standard non expert user. So, to finalize this, there are many things to discuss. So, in the form of different methodologies, how to critique a visualization, thinking about the reader, the actual data visualization that you see, we will invest our time in the next slide. So these are the learning outcomes for this module. 6 outcomes, and I want you to notice the verbs. Not one of them is understand. You will be describing, ranking, calculating, evaluating, proposing, and delivering. All things I can watch you do and even mark. The third one surprisingly make people wonder what this is. Yes, there is arithmetic in a critique. We will compute a number that says exactly how much a chart exaggerates. We have done this before. The last one matters the most once you leave the course. You will spend your career giving feedback to people who did not ask for it. And the technicality is important, and technically correct critique that lands badly changes nothing at all. The workshop that we will be having at the end of the lecture will be allowing you to treat these frameworks, the things that we learn, and learn the tools you'll pick up within the lecture to critique charts. Read those two sentences again. The difference between them is not politeness, it is traceability. The second one names a mechanism, and a mechanism can be checked, argued with, or overruled by someone with better evidence. The first one can only be agreed with or ignored. That is the whole move we are making in this learning curve. There is a second benefit, and it is the one your project partners will feel if someone is developing a visualization with you. The framework language depersonalizes the conversation. When you say the encoding is doing something, nobody has to defend their competence. Here is the test I want you holding all session. Could a colleague or a classmate, given on your evidence, arrive at the same verdict? If not, you are assessing the chart based on your taste. 6 terms quickly, so nothing trips you later. A channel is the raw visual property doing the work. Where something sits, how long it is, how dark it is, and encoding is the decision that connects a number to one of those channels. The channel is the material, the encoding is the choice. Graphical perception is the empirical bit, how accurately human beings actually read each channel, which has been measured in experiments since the 1980s. Data Inc. is Tufte's accounting device. We have talked about this earlier. Life Actor is his measuring device. And small multiples, which we will use as a fix several times in this work, is a grid of identical title charts, one per category. That is the whole vocabulary. Jock McKinley was trying to get a computer to design charts automatically, which forced him to write down what humans do by instinct. He landed on two criteria, and the order matters enormously. Expressiveness is a truth condition. Does the chart say what the chart actually wants to say? The data says. No more and no less. Effectiveness is a quality condition. The truthful options, which one do people read best? You apply them in sequence. And in expressive chart cannot be rescued by being pretty or by being easy to read, if anything. Reading a falsehood quickly is worse. So when you critique, always settle the first question before you spend any breath on the second. Inexpressiveness is subtle because nothing on the page is factually wrong. The chart simply implies more than the dataset contains. A line joining Monday to Tuesday says something real about time. The same line joining Colombo to Kandy to Gaul says a district is a step in a sequence, which it is not. The eye reads slope as trend, whether you mean it or not. Alphabetical ordering does the reverse. It hides the ranking you went to the trouble of measuring. And two unrelated series on one axis quietly asserts they belong on the same ruler. The question at the bottom is the one to memorize. Could a reader claim something the data cannot support? This table is not opinion. It is the result of experiments. Cleveland and McGill showed people the same values encoded different ways and measured the error in their answers. Precision on a shared scale won, and it wins by a lot. You have already seen this earlier. Everything below it degrades by rank, for area, people are systematically underestimating differences, and by rank 6, they are barely estimating at all, just sorting into loose bands. Two things to notice here. Pie charts sit at rank 3, which is why they are criticized, not because anyone dislikes circles. And heat maps and choropleth maps sit last, yet we use them constantly and correctly. Hold that contradiction. The next slide will resolve it. Here's the resolution. The hierarchy ranks accuracy of value reading, and value reading is only sometimes the reader's task. If I want to know where dengue cases cluster, a choropleth map at rank 6 is exactly right. I am detecting a spatial pattern, not extracting numbers. If I want to know whether Gampaha beat Kalutara, that same map fails, and a bar chart answers in a second. So the hierarchy never tells you a chart is wrong on its own. It tells you a chart is wrong for a task. Establish the task first, then rank the channel against it. And when you deliver the finding, phrase it like the sentence in the panel. Diagnosis plus alternative. Tuftay's insight was to treat ink as a budget. Every mark on the page spends some of your reader's attention, and only some of those marks are earning it. The ratio itself is rarely worth computing precisely. What earns its keep is the habit of asking. Mark my word, like, what would be lost if this disappeared? That is the important question. Usually, the answer is nothing. Drop shadows, gradient fills, heavy borders, legend duplicating, labels already on the lines, those things can be dropped in most cases. But do read the caution. Tuftay's followers took minimalism further than he did, stripping grid lines from charts where people genuinely needed to read a value. A grid line that lets someone answer a question is doing the data's work. So keep that in mind. This is the tool that changes the temperature of a critique. Instead of saying a chart feels exaggerated, which invites an argument about feelings, you hand over a number. Measure the effect the graphic shows. How much taller, how much bigger, and divide it by the effect the data actually contains. Perfect honesty is one. Tuftay allows a small band either side for drawing imprecision. Anything outside it is distortion. And it is usually not deliberate. It is a chart tool's default. Look at the example. A 5% rise rendered as a 60% taller bar gives you 12. 12 is not a rounding error, and nobody argues with 12. Name the failure and you shorten the conversation. Truncated axis first and note the asymmetry. A line chart encodes change through slope, so it may start wherever it likes, but a bar encodes magnitude through length. So cutting the bottom off is simply a lie. Dual axes are more insidious. You can slide two scales relative to each other until any two series appear to move together. So the correlation is something you manufacture. 3D adds occlusion and perspective error while carrying nothing. And radius scaling is the arithmetic trap. Double the radius and the reader sees 4 times the area. So your lie factor is 4 before you have done anything else wrong. Everything so far assumes a static image. A dashboard is not an image, it is a path and a checklist. Walk straight past what is broken. Ben Snyderman gave us the path in 3 moves: arrive and see the whole thing, narrow down without losing your bearings, then get the exact number when you finally need it. Most failing dashboards break at step 1. They open on a filtered detail view. So the user never knows what they are looking at, a subset of. Second, most common is the missing third step, where you can see a satisfying shape, but you can never recover the underlying value. Walk the path, then report the step that failed. Kaiser Fung comes at this from the other end. Everything so far has been about execution. His three questions include whether the thing was worth executing. Start with the question the chart is answering, which is often unstated and occasionally not worth asking. Then ask whether the data can answer it. This is where you catch row counts standing in for rates, a sample that excludes the population of interest, or a denominator quietly missing. Only then look at the visual. The reason to keep these separate is that they need different fixes. A design problem is an afternoon's work. A data problem means going back for different data, and no chart type will save you in that sense. Alberto Cairo's five qualities escalate. Truthful and functional are obligations. Get them wrong, and the chart should not ship. Beautiful, insightful, and enlightening are ambitions. Most working charts never reach the last one and do not need to. Use this list as a way a good reviewer uses any rubric to be specific about what already works. If you tell an author their chart is truthful and functional but not yet insightful, you have told them precisely where the next hour of effort should go. Vague praise is as useless as vague criticism and considerably more common. Six frameworks is too many to hold at once. So here's the routine table. In practice, you almost always start with a symptom. Something feels off and you cannot yet say what. Something is off and you cannot yet say what it is. Left column is the symptom. Middle column is the lens that resolves it. Right column is what you walk away holding. That right column is the point. Each framework hands you a deliverable, not just a verdict. A named alternative, a test, a number, a list of things to delete. When you write up a critique, I want to see at least two of these deliverables in it. Now, the protocol that holds the frameworks together. It comes out of art criticism and it works because it separates four things we normally do simultaneously and badly. Observe is pure description. Interpret is mechanism, what those choices do to a reader. Evaluate is where judgment finally enters. And notice it is measured against the author's goal, not yours. Suggest closes the loop with something buildable. Almost everyone jumps to step 3. The result is a verdict with no visible reason, which the author can only accept or resist. Run the steps in order out loud, and your feedback arrives with its own justification attached. It takes about 4 minutes per chart once practiced. I'm going to make you do this in silence, and you will find it uncomfortable. 60 seconds of describing a chart without evaluating it, it feels like wasted time. It isn't, for three reasons. Describing forces genuine looking. You will notice the missing axis label only when you go to write down what the axis say. It creates a shared record so the author knows you engage with what they built rather than what you assumed. And it diffuses roughly half of all disagreements because those turn out to be two people reading the chart differently. Tamara Munzern's what, why, how analysis enforces the same discipline in more formal language. Use the phrase bank. Some practical craft. Naming the principle rather than the person is not softness, it is accuracy. Because the encoding really is the thing misbehaving. Prioritize ruthlessly. One high priority fix delivered clearly beats a list of eight, which reads as an attack and gets ignored wholesale. Always state what works. Partly so the author does not accidentally delete the good parts in the rewrite. And ask who the intended reader is before you judge anything. Because a chart of a domain expert and a chart for the public are different objects. Then the panel, when you are receiving critique, write it all down before responding. Deciding and defending are separate jobs. Right, that's the theory. Now let's try to do a little critique of our own.